This video is on the topic of conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed, only transferred from store to store. But what does this really mean? It means that there is a finite amount of energy in the universe that is constantly being transferred from store to store and from object to object. Every time a change occurs anywhere in the universe, energy is transferred. It applies to really large energy transfers, like when a star explodes in a supernova, and to really small energy transfers, like when an excited electron moves to a higher energy level. In a perfect energy transfer, all the energy from one store is transferred to the other store, like with this bouncing ball. The energy transfer is 100% efficient. In reality, no energy transfer is 100% efficient. Energy is always transferred away from the object in unuseful ways. In this case, the unuseful energy transfers impact the height that the ball can reach with each bounce. We say that energy is dissipated to the thermal store of the surroundings. That means that the air is heated slightly as the ball experiences the frictional force of air resistance, and as sound waves cause the air particles to vibrate. The ground is also heated slightly due to the vibrations of the impact. Some energy will also be transferred to the thermal store of the ball. We say that these are unuseful energy transfers because this energy can't be used again in any useful way. Make sure you remember the phrase dissipated to the surroundings, as you will very likely need to use it in your exam. Now let's apply the principle of conservation of energy to an example. There are 100 joules of energy remaining in the chemical store of the battery. We leave the circuit closed until the cells have transferred all of this energy away from their chemical store. During that time, 10 joules of energy is dissipated to the thermal store of the surroundings due to resistance in the wires of the circuit, and 60 joules is unusefully transferred to the thermal store of the components in the bulb. How much energy is transferred usefully by radiation as light to the surroundings from the bulb? According to the principle of conservation of energy, energy cannot be created or destroyed, only transferred from store to store. So that means that the total energy transferred into the circuit must be equal to the total energy transferred away from the circuit. So the total energy in is 100 joules, which is transferred electrically from the chemical store of the battery. The total energy out is the sum of all the energy transfers away from the circuit. We have the 10 joules dissipated to the thermal store of the surroundings due to resistance in the wires, and the 60 joules that goes to heating the glass and metal components of the bulb casing, plus the unknown amount that is transferred by radiation as light. That leaves us with 100 joules minus 70 joules, which is 30 joules. Remember that total energy in equals total energy out. That means that all the energy must be accounted for, including dissipated energy. Let's take a look at an example exam question. Which of the following is not a summary of the law of conservation of energy? Let's look at each of the answer options in turn. A. Total energy in equals total energy out. Well, we've just explored this in the previous example, so we know that this one is correct. So that cannot be the right answer. B. There is a finite amount of energy in a closed system that can be transferred from one store to another. We've also looked at this in terms of the closed system being the universe. There is a finite amount of energy in a closed system, and it can only be transferred from store to store. So this summary is correct, and therefore cannot be the right answer. C. Energy cannot be created or destroyed. It can only be transferred from store to store by a transfer pathway. This is the actual definition with the transfer pathway bit added. And it all checks out, so this cannot be the right answer either. D. The total energy in a system is used up as it is transferred from object to object. So we know that this has to be the correct answer, but why? What's wrong with the wording of this statement? Well, it's this bit. The term used up. Used up suggests that this energy disappears, and we know that energy cannot be created or destroyed. It's subtle, but you have to pay close attention to the details in the language used. In summary, the principle of conservation of energy means that energy is always conserved. There is a finite amount of energy in any closed system. The total energy in is equal to the total energy out, and energy can only be transferred from store to store via transfer pathways. When solving energy problems, you have to account for all the energy, even energy that is dissipated to the surroundings. You may have to look closely to find some of the energy transfers, but they will always be there. Don't forget to check out all our other fantastic revision resources here at Save My Exams.